Alright, hello guys. In this video, we're going to add user registration, authentication, and JWT support as a middleware in our system. So the first thing I'm going to do is let's go to Gemini and open our chat from yesterday. Alright, and let's also look at our code too from the previous step. So before we had endpoints that weren't unprotected and are easily accessible from basically by basically anybody. So in this post, what we'll do is we'll fix that, and we'll give it a way to add users, authenticate, and you know authorize certain requests based on JWT. So what I'll do is ask it. I'll take this code back to Gemini, this handler code, and I'll ask it to add JWT middleware auth login and sign up endpoint. Ensure that stored passwords are hashed. Right, that would be a good direction. And then within the JWT, store the user ID as well as the user's IP. Take into account proxies, so like NGINX, so like it will read the IP from the headers. Store the user ID as well as the user's IP that is verified for each request. Right. Also tell it to add update the models as needed. All right. So now give it this code, and let me go back and see if I have my Postgres running, which is up running. Launch that. So Postgres is up, and then I'm also, since I might be changing the data structure, what I'll do is I'll drop my tables. So drop table post, drop table users. I think that should do it. All right, so Postgres is up. We went in, we did some changes to the database. Now let's see what changes does Go have in store for us. All right. So a few changes to the user model. We have two methods that are now introduced. I think I copied it. All right. Oh wait, bcrypt. Oh, it's bcrypt encrypted. All right, it's an external package, so we'll definitely need to run go mod tidy. All right. So we have one method to hash a user's password, and one method to compare the password. So this would most likely be used for login. And so, if you notice here, the JSON field struct for the password field is, I guess, a dash. Let's call it dash. But basically, it'll omit the password from being displayed when a user performs a query to list all users, which is good for safety. At the same time, Gorm is enforcing that our email column stays unique. So no users can have the same email. It's like the little things that count. All right, so let's see what new handler code it has generated for us. All right, so we have a few authentication. So we'll add this in its own file, and we'll call it auth handler based on Gemini, right? Oh wait, it should be in the handlers folder, so let's move it there. All right, so let's go into auth handler, and what do we have here? This is database, should not be still doesn't know that. All right. Then we have one JWT package that's being used. All right, so we'll try to download this package that Gemini gave us. Seems to be fine. All right, and our errors are gone. So now, as we start setting up JWT, there's one. This JWT package gives us the ability to set custom fields for the data that we store in the JWT, right? So in this case, we have this data structure called claims, and then under claims, we've embedded the registered claims data structure, which adds the usual JWT fields you'd see. So issuer, subject, audience, expires at. These are like your standard JWT fields. And then on top, we have our user ID and our IP address that's also being stored as per the request in the prompt that I made. And nextly, the JWT secret will be coming from our environment. So let's go ahead and export that right now. And we'll set to something secret. And this key is used to generate a hash that's verified. So basically, what JWT does is it'll take the data, pass in the payload, hash that, right? And then so when it receives a JWT, it'll recalculate that hash and see if it matches the one passed. And if it does, then the data is coming from a reliable source. Right. So setting this secret key is very important, and if you don't, it will not work. So here we have our sign up method. All right, which lets us hash password, and it'll also set the password. I'm assuming. I believe the method. Yeah, it's using a pointer. So here we're setting the password, which is good. All right, and then we have our login function, which authenticates the user and creates a JWT. All right, the Gemini should have made a function for this because we would definitely be using this again throughout the code. And here we're setting the expiration time 24 hours from now. All right, this looks good. Sign up all right. It'll just say user created successfully. That's not bad. All right, so we have our two new functions. Let's check out our middleware. See what we came up with middleware. Quite a long function. All right, a few more changes to make. So let's go ahead and add the middleware now. Now the middleware will be crucial because when the application gets a request, the request will go through this code before proceeding on to the next handler. Right now, depending on your framework, there's different ways that middleware is written. But with Gorilla Multiplexer, the function signature is having a parameter called next and having the function return an HTTP handler. So let's add this middleware into our handlers folder. So touch handlers middleware. Go. All right. Again, I'm not too fond of having this code being repeated. Right, but basically what the middleware is doing is that it's reading the token from a header called authorization. It's removing the first part of the token, which usually is bearer and then space. I usually just don't add this part and write the token directly. I haven't seen why people do set it like that. I still have more learning to do. And then so once we get the token, we attempt to map the data from the token to this claims object, which would store our IP and our user ID, which we'll use to perform different operations on the system, right? So once we've checked the token's hash by parsing it, because that's done while parsing. So once we check the hash and see if it matches, we'll then get the IP address and then compare that with the IP address stored in the token, right? And this will give us an extra layer of security where the device that the user signed in from is the device that has access to the service, right? This could be annoying too in some cases, like if the user switches networks or things of that nature. Maybe that can be built into the refresh token method. And then once we have the user ID and the IPs do match, we'll go ahead and set that within the context and call it user ID. right? So once this is in place, now we'll have to update the previous handlers that were there. And to do so, in our add post method, we're getting the user ID value from the context, the multiplexer context, and we're setting it as the user ID of the post. So a user can only make posts uh, tied to their account, right? So no longer need to provide the user ID parameter of a post. That will be populated by the add post handler, right? And lastly, what we'll do is that we'll we'll add our authentication endpoints, right? Our public endpoints, and then we'll also bind our JWT middleware to perform the checks before a post is created. We'll allow people to view the users from outside without needing to log in. So we'll just go ahead and copy this chunk of code and we'll add it into our main.go. Yeah, it's like this. Perfect. So here you see, use appends a middleware function that's called. So before the endpoint post is called, this auth middleware will be called. It'll do the different checks. It'll check if the token is valid. It'll check to see if the IP is the same as the one that was used to log in, and things of that nature. So now we have all this code in place. Let's actually begin to test it. Now, unlike the previous tests when we used Krill, this one will be using Postman. And Postman is like this neat little API client that will let us gives us a nice visual editor that we can use to test out our APIs. Right, and we're doing this before we actually use a user interface. All right, so let's do a new request. Start on a new tab. Start fresh. Start changes, and then we'll do a post request to our sign up endpoint. I believe it's sign up. Right? Yeah. We'll do it to our sign up endpoint. And I believe sign up will ask us for email and password. All right, that's not too bad. No, it won't ask us for a password. There's a bug here. I think there's a bug. Because it won't read the password from. Yeah, there's a huge bug here. We have to change one thing. The password will never reach. So we'll do this. We'll add a nested type. But yeah, that changes everything, really. So we need a way where we can hide the password from being shown, but we can't read the password when the password is coming in, right? Let's just double check. Yeah, on sign up, we're basically unable to set the password. So let's do this. Let's ask Gemini. We'll ask it to define a separate data type for sign up. All right, wait, let's see what. Huh, that's a pretty cute picture. I see login requests. All right, so this is a much more sane where we're using a different data type to parse the data and it basically allow the password to be read because that hyphen or dash the data type will never be read. All right. So let's see what we got here. Password email. All right. So we'll go ahead and add our sign up request here. All right. So everything looks fine. let's go ahead and run our application. All right, so now our sign up request will be sending name, email, and password, which is then ultimately reassigned to a user. Because this type, the password field struct is password and not a dash. So Go will actually read the data that you send through it. All right, and so let's go back to Postman. We'll do sign up, and then raw JSON. So 3 fields: name, email, and then I made a mistake here too. And then our password will be secret, right? Which is similar to the database right now. So this is our request, and then let's send it and see what happens. All right, so our user was created successfully. So we just made a new user, right? Next step will be to sign in, and just in the spirit of reusing, I think I just need to provide these two. So let's do sign, I think it was login. Let's log in. All right, so we logged in successfully, and we have our JWT token. And then we can also explore the data that we're writing to our JWT. Just extra levels of debugging. Let's say I went to jwt.io, and I can paste in a string, a JWT string. Let's see what I can do here. Or I can actually paste a string. So I paste a string. It says invalid secret. I think my secret was something secret. All right, so it's valid now. And then you can see it's storing the IP address it received from Go. In my case, it's a local machine. This way that it's storing the IP address is wrong, so we're going to change this in a bit. And then the user ID too is also being stored. So as far as the IP address goes, the port number shouldn't be part of it at all, because then we'd get like a different IP address for each request, right? So let's change that, and let's go to our login handler. So we'll ask it to make a utility function for getting the user's IP. In case a remote ADR field is used, don't include the port number. Because on a different request, our API can use a different port number. All right, so it made this really long function for us. So we'll add it in. We'll add it within the handlers folder, and we'll call it utilities. Utilities, package handlers, and then we'll add in our functionality. And then so what we'll do next is we'll go ahead and update these IP functions. Pretty much useless. All right, get client IP, and then thank you, autopilot, copilot, and then our auth handler. So that's for login. Let's also do it for middleware. And boom, like that. And then let's restart again and log in. Now, if you noticed on this utility function, if you're using something like NGINX or a proxy, the request goes through one server and goes through another. So if you were to read like the remote address directly, you would get the IP address of the server that's forwarding the request, and not the actual client or end user that initiated it. So by re-looking for these headers in setups where you're using NGINX, because X-forwarded for I think is used by NGINX, right? And X-real IP. By reading these headers, the system can reliably get an IP address, right? And in such cases, let's say both fail, then it'll read the remote address passed through with the request, right? In my case, I'm not using any proxies, so the system will be reading the IP from here. So let's go ahead and log in again and see what kind of data we got. All right, so we sent it again. We have a new JWT. go and decode this JWT. All right, so in this case now we have a much cleaner IP, which is basically a local address. I believe that's like a local address in Go. All right, so next let's try to do a request, an authenticated request to add a post, right? I remember on our post we had two fields, title, content. So we'll try to post a request to add a post, right? I think let's go see our main.go file to get an idea of posts. Right, so we'll try to post. Let's also get users first to see what kind of data we have. I don't remember it looking this bad. Oh my god! All right, I have another big problem. I'm not setting the content type on all these. So how can I do that? Do w.header. Yeah, I think it's like this. Make sure that we're encoding this data, giving it the right. I think this is otherwise I just copied and pasted it all over the wrong places. All right. Now it should show up a bit more prettier. All right, perfect. Yeah. All right. So we have the user that I just made, the username and the actual email. All right. So next up, what we're gonna do is we're going to add a post. We're gonna attempt to add a post. All right. So we'll say title, hello world, and then content of post. All right. So this is a post request that we send to our API. And if we try, all right, so we have a 401 unauthorized error, meaning that we didn't provide the necessary credentials to log in. So to do that, we'll set our header authorization, and then bearer. I believe I still have the. Oh no, I don't. So let's go ahead and copy this again, our little JWT, and we'll attempt to write a post again. So right now the post was successfully posted. Let's try to get our users just to demonstrate. Get users. All right, so we can see our post successfully made it. So hello world and the content of post. And so that's how you go about adding a JWT to your system. So you first, again, to go over the steps, you'd start with defining the data structure for your claims. So which data you'd like to store in this JWT. Once you know that, then you can proceed on to writing the code that will create the JWT and sign it for you. So in this case, we construct an instance of the claims data structure I just showed you, and then we create the token by passing the claims. Which is also, the type is JWT.claims. So we pass that, and then once we pass that, we can generate a signed string or a signed token with the signed string method. Right. And then once we have the token, we encode it and send it back as JSON. And here too, I think we're also missing the content type header. I don't know why I forgot to set that, but all right. And then so once you have the code that will create your token for you, and the user has a token, now you need some kind of middleware that you'd place in front of, that you'd place in front of the endpoints you want to protect, right? This is the first level. The next level would be controlling access based on roles, but let's build up this social media backend REST API further until we get into that. For now, we'll use a simple authorization middleware where, uh, again, once you have the claims, once you've written and signed and sent back to the client a token, you will need to pass this token through here before giving the user further access into your system, right? And a few extra things in this code. We're using we're comparing the IP address as an extra means of security. But again, this will break if the user changes networks or anything of that nature. But for extra security, I think that works pretty well, unless IP spoofing is uncontrollable again. And then so once you have the off middleware, then the system is pretty much all set to go. Um, you know, and as I demonstrated, you can't access the post endpoint without providing a token. If we were to move these handlers in here, the same rule would apply. Where if we don't provide the authorization token, and you know what, I think we should actually do that. Let's go ahead and we'll move these two endpoints into you know to our so by registering the handler on the protected router, these endpoints to automatically become secure. So let's restart this server, and then let's go ahead and try to get the users. In this case, we're not providing any token or any kind of authorization. And if we try to get our users, we'll get the missing authorization header. Um, if this was to be used in a front end with Vue or React, we definitely need to have this error message. Use JSON, and yeah. So let's do the request again with the token. I think the key was authorization. All right, and boom, we get the users now. All right, so this has been JWT. In the next video, we'll look at developing the features of the social network even further. So we'll give users the ability to follow users and then see how we can generate a news feed with Gorm instantly without too much hassle using Gemini. Thank you for watching. Also, I'll start now adding links to the GitHub with the full source code of this project. So I'll add that after I finish this video. I'll go ahead and create a new repository for it, and I'll call it YouTube Gorm API. Thank you for watching.